Good morning, everyone. Today, I will go into walk you through a practical DevOps project where we automate server configuration using Ansible and Docker. In traditional environments, testing up servers is often manual, repetitive, and error-prone. But with the right tools, we can transform this into a fully automated and repeatable process. In this session, you will see how to simulate multiple servers using Docker, how to connect to them via SSH, and how to automate everything using Ansible. By the end, you will understand how to treat infrastructure as code. System architecture. Let's start with the big picture. Our system has three main components. 1. Ansible control node. This is your local machine. Multiple Docker containers acting as servers, communication via SSH. Instead of using real cloud servers, we use Docker containers to simulate them. This approach is lightweight, fast, and fit for learning. Its container behaves like a real Linux server. It has SSH access. It runs service like Nginx, and it can be configured remotely. So conceptually, this is very close to a real production setup. Project layout. A clean project structure is critical in DevOps. Here is how we organize our projects. Inventory file define our servers. Playbook YAML file, automation logic. Ansible config file, configuration. Docker folder, container setup. Docker compose YAML, multi-container orchestration. Files folder, static access like HTML. This structure helps us keep everything modular. Scale easily when adding more servers. Maintain clarity as the project grows. Good structure is the foundation of scalable system. Docker as servers. Why Docker? Why do we use Docker instead of real servers? Because Docker gives us lightweight environment, fast startup time, easy reproducibility. Instead of provisioning EC2 instance or virtual machines, we can spin up multiple servers in seconds. Each container has its our file system, runs its our process, can be accessed via SSH. This makes Docker perfect for DevOps and testing automation. Dockerfile. Build SSH enabled servers. Let's look at how we build our server image. We start from Ubuntu and install. Open SSH servers to allow remote access. Sudo from privilege escalation. Pattern 3 required by Ansible. We also configure the environment to be non-interactive to avoid installation issue. The key idea here is we are building a reusable server template. Every container we create from this image will behave consistently. Docker Compose. Multi-container setup. We use Docker Compose to run multiple containers. Each container represents a server. For example, port 2222 for SSH access, port 8081 for web server. This mapping allows us to connect via SSH, access the web service in a browser. With one command, Docker Compose of, we can run an entire multi-server environment instantly. SSH connection. That's connectivity. Before using Ansible, we must ensure SSH works we test it with SSH root localhost. If this works, it means the container is readable. SSH is correctly configured. We can control the server remotely. This step is crucial because Ansible relies entirely on SSH. Ansible config. Setup Ansible. Now we configure Ansible. In Ansible config file, we disable hotkey tracking to simplify connections. Then we define our inventory. Web 1 access port 2222. Web 2 access port 2223. The inventory tells Ansible. These are the servers you will manage. These adjustments allow us to scale easily by just adding more entry. Test Ansible. First command. Let's test Ansible with a simple command. Ansible web ping. If everything is set up correctly, we get success. This confirms SSH connectivity works, but Python is available. Ansible can execute remote tasks. At this point, our automation system is ready. Ad-hoc command, quick operation. Ad-hoc commands are useful for quick one-time tasks. For example, Ansible web command did install Nginx on all servers instantly. Use cases include debugging, quick fix, testing commands. However, ad hoc commands are not ideal for long-term automation. For that, we use playbook. Playbook automation scripts. Playbooks are the core of Ansible. We define what to do, where to do it, and how to do it. A playbook is essentially instructor as code. Benefits include repeatability, version control, scalability. Instead of manually configuring servers, we define the design state. Task flow. What happened? Let's break down the automation flow. When we run the playbook, Ansible performs. First, update system package. Net install Nginx. Net create necessary directories. Net copy HTML file. Net start the Nginx service. Each step is defined as a task. Together, they form a fully automated deployment pipeline. HTML development. Web content. We deploy a simple HTML file. This file is copied to HTML folder. Once deployed, Nginx will save this page. This proves that our automation works end-to-end. Run playbook. Execute automation. To execute everything, we run Ansible playbook command. In a single command, we install software, configure servers, deploy application. This is the power of automation. Verify. Check the result. Now we verify the result. We open localhost. If everything is correct, we see our HTML page. This confirms Nginx is running. The website is deployed. The system works as expected. Always verify your automation. Idempotencies. One of the more important concepts in Ansible is idempotencies. If we run the playbook again, Ansible playbook command, we get Nginx equals 0. This means no unnecessary changes were made. The system is already in the design state. Idempotencies ensure stability and safety. What we learn. Let's summarize what we learn. Inventory means define servers. Ad-hoc command means quick operations. Playbooks means full automation. SSI means agent-led communication. Idempotency means reliable system. But more importantly, we learn how to think like a DevOps engineer.